Resistors. A circuit requires a resistance in order to operate. If the resistance performs a useful function, it is referred to as the load device. However, resistance can also be used to control current flow and the sensing devices for computer systems. There are several types of resistors that may be used within a circuit. These include fixed resistors, stepped resistors, and variable resistors. Fixed resistors. Fixed resistors are usually made of carbon or oxidized metal. These resistors have a set resistance value and are used to limit the amount of the current flow in a circuit. The resistance value can be determined by the color bands on the protective shell. Usually there are 4 or 5 color bands. When there are 4 bands, the first 2 are the digit bands, the third is the multiplier, and the fourth is tolerance. On a resistor with 5 bands, the first 3 are digit bands. For example, if the resistor has 4 color bands of yellow, black, brown, and gold, the resistance value is determined as follows. The first color band, yellow, gives the first digit of value 4. The second color band, black, gives the second digit value of 0. The digit value is now 40. Multiply this by the value of the third band. In the case brown has a value of 10, so the resistor should have 400 ohms of resistance. The last band gives the tolerance, called equals the tolerance range of minus plus 5%. Stepped resistors. A stepped resistor has 2 or more fixed resistor values. The stepped resistors can have an integral switch or have a switch wire in series. A stepped resistor is commonly used to control electrical motor speeds. By changing the position of the switch, resistance is increased or decreased with the circuit. If the current flows through the low resistance, the higher current flows to the motor and its speed increases. If the switch is placed in the low speed position, additional resistance is added to the circuit. Less current flows to the motor, which causes it to operate at a reduced speed. A stepped resistor is also used to convert digital to analog signals in a computer circuit. This is accomplished by converting the on-off digital signal into a continuously variable analog signal. Variable resistors. Variable resistors provide for an infinite number of resistance values within a range. The most common types of variable resistors are rheostats and potentiometers. The rheostat is a 2-terminal variable resistor used to regulate the strength of an electrical current. A resistor has one terminal connected to the fixed end of the resistor and the second terminal connected to a movable contact called wiper. By changing the position of the wiper on the resistor, the amount of resistance can be increased or decreased. The most common use of the rheostat is the instrument panel light switch. As the switch knob is turned, the instrument lights dim or brighten depending on the resistance value. A potentiometer is a 3-wire variable resistor that acts as a voltage divider to produce continuously variable output signal proportional to a mechanical position. When a potentiometer is installed in the circuit, one terminal is connected to a power source at one end of the resistor. The second wire is connected to the opposite end of the resistor and is the ground return path. The third wire is connected to the wiper contact. The wiper senses the variable voltage drop as it moved over the resistor. Because the current always flows through the same amount of resistance, the total value drop measured by the potentiometer is